Okay, so I know it's 5 o'clock. You're all guys thinking about food and drinks later on, so let's have a bit of fun before we break out this Spark Summit. So today, I'm going to talk about how to turn everyone into Spark SQL monkeys. No, I'm kidding. This is my secret master plan. Really, what we're going to talk about today is how to solve low latency over big data with Spark SQL and in Microsoft. So, what we're going to talk to, we'll start with some introduction, look at the project, mission, a use case, some learnings, and how we've implemented, these learnings, and some of the future of Spark in ASG. Okay, so who am I? I'm Julien. I've got a Chinese name as well, which is Julien, or Julian. I'm a senior product manager for the application services group. In a shared data team. I'm based in Beijing, and I'm working on Spark, and specifically, obviously, running Spark as a service for Microsoft internal teams. I also drive, the Spark community, the internal community within Microsoft, along with other colleagues, of course. I worked previously on Office 365 admin experience and on customer-facing reporting. I also open sourced the Office 365 Splunk app. How many of you used Splunk in the past? Yes, one, two. And do you guys know about Office 365 Splunk app? No, you should try it. Okay, I want to make something a little bit clear here. If you search my name on Bing, there is another guy called Julien Pierre. He's a French Ruby player. That's not me, okay? I'm the second link on that page, okay? Just to make things clear. Okay, so what do we do? The shared data team have, really is two big blocks. It's client data fluency and modern data capability. So client data fluency is really, we own the data, the curation, the transformation, and the aggregation for Office, Skype, and Bing teams, which means that we deliver data sets, data streams, and metrics layer on top of the data sets, for these customers. And when I mean customers, these are like data analysts, data scientists and engineer within Bing, Office, and Skype. The modern data capability really means that we own the infrastructure for these teams, from instrumentation and ingestion to experimentation and reporting analytics, for example. And the Spark work really spans across processing and storage and reporting analytics. Okay, so this is our project mission. We want to deliver interactive analytics, for ASG teams to build great products, right? We want those teams to focus on building great products and not on running, infrastructure. And so what does that mean? First, we want to increase the analyst, and engineer productivity by providing them some very simple self-service tools so that they can, find new insights and resolve their issues very, quickly. Second is capitalize on our data. That means we want to provide those well-known data sets and data streams in a more consumable ways, than before. So this means that those very high-level APIs and standard query language. And last but not least is leverage open source technology to run a stable service, by leveraging the community, but also, and more importantly, to contribute back. Okay, so the use case. I had many use cases to choose from, but I actually choose a very simple one, so just to demonstrate, the topic of this session. So the use case is, actually, before we do that, basically in Microsoft, we have, as you know, Microsoft SQL Server, which is great for low latency, but it's small data. And on the other end of the spectrum, we have Cosmos, which is an internal distributed storage and computation system, which is really, really great for really big data, but it also comes with a high latency. So we use Spark to fill the gap between the two. OK, so this is the data issue troubleshooting use case. And this is Kuntao, one of the engineers on my team. And Kuntao already receives an email from one of the customers in the Office teams and says, this customer already uses the Office dataset. And it turns out that one of the field, the created date field, is equals to the minimum date, which is the first of year one. So Kuntao has to find out whether this is a bug or is it by design. And there's about 71.2 terabytes of data, Office data, for this particular data set. So let's troubleshoot this issue, first from Cosmos and then from Spark. So typically, running those kind of jobs involves writing a query, compiling, submitting, waiting, and for the job to run and complete, and visualizing the data in some interfaces like Excel. So in Cosmos, the first thing you had to do was to check the affected records. So you had to write a query, submit it, and wait, et cetera, and then at the end, open up export the file in a flat file, and open it in Excel. Then, so he fetched the records, look at the data, and runs another query to find the root cause, and then finally assert his findings. Say, okay, in this particular case, Kuntao found out that it was by design because a subset of the data had a specific flag, for which those records had the credit date field set to the minimum date. So let's look at the same thing, but done with Spark. So Kuntao had to go through the same process, the same iterations. He had to run the same queries, but he used those Spark SQL and SQL on Zeppelin to do those very simple queries and view the results inline within the notebook and in a very nice formatted table. And so first of all, it's much faster. So he basically saved 2/3 of his time. So let's look at actually the time itself. So I actually prefer looking at the elapsed time, so the end-to-end flow instead of the running time, because the running time, yeah, it's supposed to be faster. It is actually faster, but you have to think about the actual analyst flow, right? You have to open your IDE, or you have to open up a web page on Zeppelin, whatever. You have to write your query, you have to compile it, you have to submit it. So all in all, even though Spark SQL and Spark SQL with cache is much faster to actually run the query, but the end-to-end flow is also much faster. So this is about, so the figures really, Cosmos is about 176 seconds, whereas Spark SQL is 50 seconds. So the important bit here is not the time of the query. It's the fact that the analyst with Spark can do more iterations. He or she can actually do more of this analysis, and in the end, we can find more insights and more solution to problems. And consequently, we can build better products. So this is really the key here. OK, so what did we learn in this process? So the first thing we learned is that the users wanted to move their own data from Cosmos to HDFS and obviously consume data from Spark. And they also wanted to upload some flat files in HDFS to do some kind of local analytics. So we've enabled self-service, and I have a few slides to talk about that after. The second thing we've enabled is the things we've learned is actually minimize time to insight. So this is, again, this concept that from the time that the analyst has a question that needs an answer to the time the analyst actually presents the final data product and shares the data product with his colleagues or whatever, right? It's the whole end-to-end flow. Previously, without Spark and without the Spark ecosystem, you had to work with Cosmos, do those really time-consuming queries, export data into flat files, put into Excel, maybe upload this into Power BI and so forth. So it's very time-consuming and not really great. Even in R, you had to export into flat file, import the flat file into R, and this was really not user-friendly. So minimizing time to insight is that. There's a couple of things really. There's two things to look at. Is the faster response of getting faster response on really hot data, and the visualization part. So on that note, we're currently working on enabling Tachyon between HDFS and Spark, and we're actually making one on Windows, and it's not easy. So actually, we're working, with some great engineers from Tachyon Nexus, and it's really a good thing that we work together to enable this, and hopefully we'll have something working, by the end of the summer. And the last thing we learned is that obviously notebooks, as you probably know, is quite an interesting user interface, but we've used Zeppelin a lot. But it's not scalable, actually. Zeppelin itself, if you just use Zeppelin out of the box, is actually not scalable. So there's a lot of work to be done to make Zeppelin work at scale in a multi-tenancy environment. And the fact that Zeppelin has a single driver, which basically shares the Spark and the Hive context between all the users, that makes the concurrent work between analysts very impossible, almost impossible. So from next month, we're going to be working on scaling out the backend of Zeppelin to enable having one notebook being one isolated application within a Spark cluster. OK, so how did we do it? So, and specifically, how did we enable this Spark SQL like interactive query and self-service scenarios? OK, so let's look at some the architecture. So we have Cosmos at the bottom. Excuse me. So Cosmos, as I said, is the storage part, is where all the data that we have in Office is stored there. And we run a Mesos cluster on Windows. Yes, we are running Mesos on Windows, along with HDFS. Then we've obviously deployed Spark, the 3 server, and a MetaStoreDB to enable the ODBC connection to Rover and Avocado. So Rover and Avocados are internal querying tool. So Rover is more like a drag and drop a tool. It's they're all web-based tool that generates the query, the backend query. So the user doesn't have to worry about the actual query language itself. Avocado is a more generic querying tool. It does also task and scheduling. And obviously, we've connected Avocado to that. The next step we did is Zeppelin. So we deployed Zeppelin, and we've separated the front end from the back end. So we have the front end running on some servers, and the back end running on other servers, which enables us to really work on the back end to scale out the notebook and the remote interpreters. And the last bit we worked on is the job management to enable that the download job between Cosmos and HDFS. So we built a front-end web API, which is a RESTful API, and it's built in .NET since we run on Windows, and also our engineers are actually familiar with .NET. So it was very fast for us to do that. So we have the RESTful API, we have a job manager, as well as a driver host pool, which is coordinated by a zookeeper. And the last bit that we did is the Hive loader, and I have more information on that after. OK, now let's look at the Cosmos to HDFS job. So you have Cosmos. In Cosmos, you have streams, and streams are partitioned. And essentially, you have one Spark job with two stages. And the first stage is really about extracting the stream from Cosmos and exporting it as a CSV, and then copying the file to HDFS under a CSV folder. And then the stage 2 really converts the CSV into Parquet. From that, the Hive loader is a convention-based loader. So it looks at the root. It kind of scans all the root folders in HDFS. And usually what happens is we have the root folder being a team name, which will then correspond to the database name in Hive. And then the subfolders will correspond to table names. So automatically, as soon as you move your data into HDFS, it will then show up automatically in Hive. And since the Metastore DB is actually shared between Zeppelin and Hive, then the users can actually query the very same data between the two interfaces. OK, user experience. So we wanted to make it very simple for users to move data from Cosmos to HDFS, obviously. So the only two things we've asked the users to provide is the source path in Cosmos and the destination path in HDFS. And from that point, once the task is created, they can create a schedule. And the schedule can be daily, hourly, daily, or weekly, or whatever, monthly. And they can also backfill the data if they want to. From that point, when the job is running, from within Avocado task UI, they can access the Spark driver UI to investigate the stages and tasks from within Avocado, from within Spark. They also have access to the standard output and standard errors files. Once the job is completed, obviously the driver UI is not there anymore, but they have the job history server URL, which they can look back and what happened to the job itself. And this really helps in the troubleshooting scenario when the actual task actually fails. OK, so what's next? So this is really a slide about the vision of analytics as a service in ESG. And again, this is really like internal, like how we make our people more data-driven. And as Gloria, Leo yesterday at the keynote, how do we make people SQL monkeys, right? This is what this is about. So, on the left-hand side, you have those traditional pipelines plus the NLT pipelines. So you have clients and services that produce data, gets ingested into those pipelines. They get transformed, they get computed, and then really what you have is a data product. You have a data stream, you have a data set. Before implementing Spark, the analyst and the engineer had to deal with several systems, several APIs to consume the data and to get something out of this data, right? And it was usually very time-consuming, and usually took weeks. You had to actually create a feature crew for getting something done, and so not very efficient way to actually consume data. So what we did is we added Spark in the middle, between the human being and the pipelines, and as a complementary piece to this overall pipeline. And the interesting piece here is really those different experiences. So you have the synchronous experience and the asynchronous. So what I mean by asynchronous is when the analyst sits in front of his or her computer, writing some query or some code, and waiting for the result to come back. And this has to be super fast. It has to be interactive to really enable that iterative and interactive analysis and to find those new insights. The asynchronous experience is about building a Spark application and submitting that application to the cluster and basically do not wait for the result to come back. And usually you don't want to wait because the result will be fed back into some other pipelines, maybe directly to Office 365 or Bing directly. So this is really the idea. Okay, this is the last slide I have for you today. I personally look at Spark as the data analyst hub because it's truly this powerful platform that really allows multiple data sources and multiple tools. Yeah, you don't have to enforce someone to use a specific user interface to consume data. If you want to use Tableau, use Tableau. Yeah, if you want to use R, use R. If you want to use Avocado, that's what you will do. This is the beauty of Spark, to my sense. So we've done several work to enable, for example, DataZen. So DataZen was acquired by Microsoft a couple of months ago, I think. And we basically simply created an ODBC, a custom ODBC data provider in DataZen, and that was it. That was done. It was very, very quick, and the analyst could create, discover data, prepare data in Zeppelin, save back the information to HDFS, and then create a KPI directly into DataZen, and then you have it on your phone. Boom, a few minutes, it's done. Whereas before, you had to go through weeks of engineering to get something done like this. So I think it's really awesome. So Spark really enabled for us something that was really complex. It really allowed us to make something very easy and enjoyable to do. Thank you. Any questions?
So, Julien, interesting talk. Could you go back to the slide where you showed the data going from Cosmos to HDFS and then Parquet? Yes, this one. So how long does it take for you to ETL the data from Cosmos to Parquet?
It depends on data size, obviously, but for very tiny data size, like maybe I don't know, like a megabyte or something like that, it takes a couple of minutes.
Right. No, I'm talking about the big data. So these data set that you were showing earlier is 72 terabytes, right?
Right. So again, it depends. It depends. How big is it? So like for the Bing, you want specifically for Bing data sets? Well, I didn't look at the actual numbers, but.
What I'm trying to get to is, so if you have those huge data sets, right, terabytes of data set.
Yeah.
How frequently are you doing that extraction, right? And if it has to be done extracted,
yeah,
then your analyst doesn't really have access to the data in real time. He has to kind of wait till that batch extraction takes place.
Yeah. But traditionally, we have a day latency. If all the data that is actually in Cosmos, most of the data in Cosmos is already a day late, anyway. So we process depending on the actual underlying stream. So there are hourly streams. In that case, we would move the data hourly. Okay. So obviously, depending again on the data size, it would be faster or quicker. But if the actual stream is created daily, then we can't move it hourly. It's not possible. So we have to wait until the stream actually exists in Cosmos to then move it to HDFS. So typically, it's always a day late.
Okay. So one more question. So the numbers that you showed, right, where I think on this 72 terabyte with Spark and Tachyon, it was like 50 seconds. How big was the cluster size to get that latency? So
our cluster is about 400 nodes.
Okay.
I can't remember exactly the size of the memory. I'm sorry, I can't remember how much memory we have. Okay. But it's about 400 nodes.
Okay.
Yeah.
Thank you.
So Tachyon is something that we've just started, about 3 weeks ago, and it really it was first investigation stage where is it actually possible to run Tachyon on Windows, and this really involves, doing some porting work. And last week we had a first version working, but it's not properly configured, so there is no added value there. And so we need to work further and make it work properly. Yeah. Yes.
So you said you're writing your applications using the .NET framework, then you consume data from Spark server. So did you have to? Yeah, go ahead.
So actually, the applications or the Spark applications are written in Scala. Mm-hmm. The job front-end web API is a .NET API, a RESTful API. So it's not the actual Spark application, it's in .NET.
Okay, but does the .NET application have to consume any data from Spark?
No, really, the front-end API is just, it doesn't have to be in .NET. It could be anything.
Right.
It happened to be in .NET because we are used to that. And what happens behind the scene, it allows the engineer to submit, to basically tell the cluster, run that job. And then the job manager will then put that, provision like a driver host for that. And the zookeeper coordinates those hosts. And the job gets scheduled and then run into a cluster. And because we have a resource manager, the resource manager will allocate the workers for that job based on the configuration, and that's it. So the .NET element of that is not really important. It's just a gate through to access the job manager, really.
Okay, yeah, we were just looking for an ODBC driver, and I thought you would have done the same thing.
So, but the ODBC driver is already existing,
So which driver did you have to use? Is there a specific driver?
Do you mean to run on Windows?
Yeah.
So you can download the Microsoft Hive ODBC driver. If you Bing that, if you Google Bing that, whatever.
I did, and actually it was a little slow. That's why I was looking for other options. But yeah, it was one of the options they have.
Yeah, it's actually based on the Simba. Simba. Yeah, it's literally the same thing.
Okay, thank you.
Another question now.
Any other questions? Oh, one back there.
So do you ever consider to have some strategy to support maybe hierarchical system, for example, maybe for the code data, maybe a very large code data, you can just direct visit the Cosmos, and for the maybe small or maybe for HDFS data, so you can use the Spark to get the answer. So maybe as soon as possible.
Did you say Oracle?
Sorry, do you have some strategy to maybe to help the user to decide that automatically? So.
Oh, so is your question? Do we have a strategy to
fetch data from different storage levels?
Oh, for different storage.
Yes.
Okay. So today, no, but I think it's very much in our plans, in our ideas. The whole data analyst hub is about this. It's like I have data in Spark SQL, in SQL Server, and so I should be able to fetch that. But I think we have to work a little bit further with Tachyon. I think Tachyon can be a intermediary layer between Spark and the underlying data sources, and this is potentially a way for us to store some data there. So we have to look at it.
All right, we might have time for one more question, if anyone has any questions. Okay, then let's thank Julien again.
Thank you.